Hi there, welcome to this series of videos on programming logic. We would start with simple programs like even numbers, odd numbers, how to find if a number is prime, find factorial of a number, and then move on to complex data structures and also algorithms. One very important thing to remember throughout this series of videos is all these videos are language neutral. Even though all the examples which we are seeing are from C, it equally applies to languages like C++, Java, and C#. If there is a difference in how things work in a different language, then that would be discussed separately. But the concepts which we discuss and the logic which we use to run the programs would be the same in all the languages. So whether you're using C, C++, or Java, these videos would be very useful to you. In this video, let's look at what happens when we declare a variable, how it is stored in memory, and also we'll look at assignment operator. These two concepts are very important if you want to get a good hold of programming logic. So let's start with variable declaration. The way we declare variable is very simple, right? You would have looked at programs where this is done. Int I, this basically declares a variable. What is a variable? A variable is something which has three things. A is a type, it has a name, and it has a value. So the type of the variable which we are creating here is int. The type of the variable which the name of the variable is I, and the value of it right now it doesn't have any value. If I say I is equal to 25, now I'm assigning a value to it. At the end of statement 1, where I've just declared int I, the value of the I would be garbage. What happens when I say int I is in computer memory, like in the memory of the computer, in the main memory most probably, what happens is a box like thing is created. So you can treat memory as like a box. So when we start off, when we create the int I, this would have some garbage. So what basically happens is in this, the content of this probably might be something like 1 lakh or something. Some garbage value would be present at the start. And at the end of this statement, if you look at this statement is I is equal to 25. So when we come to this statement, what happens is the value of I gets overridden. So this 1000 is replaced by value 25. So this is what happens when I say I is equal to 25. What happens is the value on the right hand side, which is 25, it gets stored into the variable on the left hand side, which is I. So whatever value, whatever garbage value I had earlier would be replaced by the value which we are assigning to I, which is 25. Similarly, let's say I have a variable, another variable created J. So now even J would have its separate box created. So now what happens in memory is actually a separate box is created for J. So J would have something of the same kind, a box where we can store the values of J. So what happens is the value of J would be stored in this particular box. So what happens now is another box like this is created, and inside this the value of J is stored. So let's say the value of initial garbage value of J is 6, 7, 8, 9, some random value which is present in memory. So now what I'm doing is I'll assign something like J is equal to 100. So what happens now when code execution comes to this line, J is equal to 100, is simple. I think you'd be easily able to get it. In this box, a value of 100 is stored. So let's now look at what would happen if I say I is equal to J. This is something which usually confuses people, the assignment operator. The assignment operator is equal to, and people generally confuse it, like new programmers generally confuse it with the is equal to in mathematics. So when I actually say I is equal to j, what does that mean? Does that mean the values of I and j are equal? Actually, it's a little different. What this is an assignment operator. What the assignment operator does is it takes the value in the variable on the right hand side. So this is the variable on the right hand side, right? So this is j. J is the variable on the right hand side. So the value of j, whatever value is present in j. So if you look at the value in j at this point, it's 100, right? The box j contains a value 100. So what happens is the value in j is going to be put into the value in I. So since this is I mean this is basically the box which we assumed to be I. So this is I and this we know is the box j. So what happens is at this point when this line is executed, when I is equal to j is executed, the value, whatever value is stored in j, the value which should be stored in j at this point is 100. So this value 100 is stored into the value I. So what happens is the value of I, 25 right now, gets overridden by the value 100. So this is how the assignment operator works. Whatever value is present in the variable or the expression. When we say expression, I can say I is equal to j into 2. What this does is the expression is evaluated. So j into 2. So value in j is 100. 100 into 2 is 200. And the value would be stored into I, which is 200. So now let's complicate it a little further. So what happens if I say I comma j comma k, and I will not initialize k to any value, and I would come over here. Let's also put some value in there. So k is equal to 50. So now I say k is equal to j is equal to I. What happens? What would happen when k is equal to j is equal to I? What would be the value in k? What would be the value in j? And what would be the value in I? What happens when I create a new variable k is we get some memory allocated to it. So another box is created in memory where the value of k is stored. So what happens is I have another box where I can store the value of k. So now when the code executes, this line executes, I value would be becoming 25. So this would become 25. When this line executes, j becomes 100. When k is equal to 50 is executed, the value in k would be 50. And when I is equal to j into 2 is executed, j into 2 is 200. So 200 gets stored here. And next k is equal to j is equal to I. What happens here? So when the way the assignment operator works is it starts from the right hand side, and whatever value is inside that is assigned to the left hand side. So what happens is j is equal to I is the first thing which gets evaluated. So what happens is the value in I is 200. So what happens here is the value from I is stored in j. So this 200 gets stored in j. So one important thing about the assignment operator is the assignment operator returns the value which has been assigned. So the value which is assigned to j here is 200. So what happens is actually j is equal to I expression also carries the same value 200. If I said j is equal to I star 2, then this expression would have carried a value I into 2, that is 200 into 2, that is it would be 200 into 2, that is 400. So if I say j is equal to I star 2, it carries value, the value 400 is stored into j, and also this expression which is present here, j is equal to I star 2, carries a value which is same as the value in j. So this value gets assigned into k. So now what happens is if I execute the expression as it is here, I into 2, the value of I as it is right now is 100 into 2, that is 200, which is already stored in here. So what happens is I star 2, that is 200 into 2, which is 400, gets assigned and stored into j. So the value of j becomes 400. And now the expression j is equal to I star 2 has a value 400. that value would also be stored into k. So now the value of k becomes 400. So now let's all this might sound a little complicated. Let's use a feature in Turbo C++ called watch to see what values are present in each variable at each point. The way you can add a variable is just double click on the watch window and say I, and I'm adding j and k. So now I can start stepping through the code by using the key F7. So now I press F7 and now I can start stepping through. If you see right now, before this start of execution program, all the watch window values are undefined, so they don't have a value right now. I'm going in and you see the values have some garbage value. So as soon as they are declared, I, j and k get some garbage values. So I has a value 646, j has a value 652, some garbage value is present. So now if you see, I am executing the line I is equal to 25 and the value of I now changes to 25. The value of j is going to be assigned to 100, so j is equal to 100 and k is equal to 50. So the value of k changes to 50. So now we are executing the expression I is equal to j into 2, which is the value in j is 100, 100 into 2 is 200, so 200 gets stored into I. So the way assignment gets executed is the value from the right hand side expression is stored into the variable on the left hand side. So it gets stored into the variable on the left hand side and the value of I becomes 200. So now if you look at this particular statement, this is k is equal to j is equal to I star 2. What happens is I star 2 gets executed and then that value is stored into j and the value of j is stored into k. So if you look at the values at the end of this execution, I star 2 is I is 200 into 2, which is 400, and the 400 gets stored into j and that value would be stored into k as well. So if you look at it, j and k would be changing to 400. Let's write a program to find out if a number is odd or even. Let's start with writing a simple program which just prints something to the output. Then we can move on to writing a function which does whether a number is even or odd. One thing to watch out for is if you are already experienced in programming, you might find the first couple of videos a little slow. So if you're already experienced in programming, probably you can give a couple of programs a skip and start with something which you already don't know. But in this first few videos, I would want to go a little slow so that even somebody who's a starter in programming would be able to follow them. So now let's get started. Let's write a program to find out if a number is even. So what I've done is created a simple variable int number and I've assigned a value 10. Yeah, I've hard-coded the value in there, but let's just write a program to print whatever value is in number, is it even or not. The logic to determine whether a number is even or not is very simple. If a number leaves a remainder 1 when divided by 2, it's odd. So if 11 when it's divided by 2 leaves a remainder 1. So and 10 when divided by 2 leaves a remainder 0. So any number which leaves a remainder 1 is odd. Any number which leaves a remainder 0 is even. So now the operator which helps us do that operation is modulus. This modulus operator is present in almost all the programming languages. The modulus operator gives us the remainder when a number is divided by another number. So if I do a 10 mod 2, it gives me the remainder when 10 is divided by 2. We can use that operator to find out if a number is even or not. The other important operator which would be introduced in this is the comparison operator. So the way it works is if I say number mod 2 is equal to 0, what happens internally? So we looked at the assignment operator in the previous videos, which is single is equal to, which is number is equal to 0, actually stores a value of 0 into number. So what happens when I say single is equal to is the value 0 gets stored into the box number that we saw in the previous video. However, the comparison operator, which is double is equal to, this is called the comparison operator. The comparison operator is a little different. The comparison operator actually compares if the left hand side and the right hand side. The left hand side is number mod 2, so the value which comes when number mod 2 is evaluated, and the right hand side, which is 0 here. If these two are equal, then this expression returns a non-zero value, which is indicating that it's true. So basically, when you want to compare two things, if I want to find out if number mod 2 is 0 or not, I want to check whether when I do a modulus of 2 over a number, whether it returns back a value 0 or not. In this situation, I'll use the comparison operator. So what I want to do is, if number mod 2 is equal to 0, then what we want to do, printf number is even. So let's use the else as well and say printf number is odd. So one important thing to remember is the use of the comparison operator. The comparison operator is double is equal to, and this is a common mistake which beginners to programming make. The difference between is equal to and double is equal to. Double is equal to is a comparison operator. It checks whether the left hand side value is equal to the right hand side values, whether it number of, when I do number mod 2, does I get 0 or not, do I get 0 or not. If I get 0, then print that number is even, else number is odd. So let's just run this program and see what happens. Let's debug the program and check what the output is. So I'm doing a F7, which is debug in Turbo C++. If you're using a different IDE, probably you can use the debug mode there as well. When I press F7, it starts stepping through the program line by line. Now a number is assigned a value 10. What happens now is the clear screen, so you can see the output clearing out. What happens now is, if number mod 2 is equal to 0, the number has a value 10, so 10 mod 2 is 0. So this condition would return a non-zero value indicating true. So now if you look at it, it runs, it executes printf, and there you go. In the output, its printed number is even. So let's complete the execution. Now what I'll do here is also change the value to something else. Let's say I want to change the value which is present here from 10 to an odd number. Let's say I give a value 15. So if I do this, number has a value 15, and if you look at it, does a clear screen now, the output is cleared off, and number mod 2 is now having a value 1. So number mod 2 is equal to 0, number mod 2 is 1, and 1 is not equal to 0. So this returns a value 0, which indicates false. So the code goes to else and it prints number is odd. So this is how you write a simple program to determine if a number is odd or even. Now what we'll do is actually create a function. So what I'll do is actually create a function which returns even or not. So I'll call it is even. The function is even, and it returns a type int back. If you're programming in Java or C#, you have a type called boolean. Boolean indicates whether it's true or false, but in C you don't have a value boolean. We only have a value int. When a value is non-zero, that's 2 or 5 or 6, it's true. When a value is 0, then it's false. But if you're doing Java or C#, you can use the return value as a boolean. Here we don't have a boolean in C language, so I use int is even, and I'll pass the number which I want to check is even or not as the parameter. So the number I would want to pass is an integer, so I'll say number, and I can say if number mod 2 is equal to 0, then we would want to return a value 1. 1 indicates true, else return 0. So now let's run this program from execute this function from main with different values and see what happens. So I'm going to clear all this stuff out, and let's write printf. Let's do a clear screen first, then do a printf and 11 and say %d. I would invoke the function from here. The function is even, and I want to pass a value 11. So let's see what happens, and then printf. I'll pass in a value 20 and %d comma is even of 20. So if you look at the return values would be 1 or 0. 1 indicates that it's even, and 1 indicates that it's odd, and 0 indicates that it's even. Let's run this program and check what happens. The first thing which happens is the clear screen, obviously, and then if you look at this, the isEven function is called with a value 11. So isEven 11 mod 2 is not equal to 0, so it goes to else and returns a value 0. That indicates that the value which 11 is not a even number. So if you see in the output, you can see 11 and the value returned back is 0, which indicates that it's not even. And if you look at the next function it's called with 20 mod 2 is 0, so it returns a value 1 back, and now this function returns a value 1 back, and I'm printing that to the output. So 20 is even. So that basically is how you write the even odd program. Like similar to isEven, you can also write a program for doing isOdd, which is exactly the reverse of the isEven function. If you want to, actually I can add in a logic saying if is even, print even and print odd, but I think 0 and 1 are simple enough to deduce. So there we go. That's our first program, is even and is odd. Let's write a program to find out if a year is leap year or not. The logic to find a leap year is very simple. If let's take a year 1904. This 1904 is a year which is divisible by 4. So if I just take the simple logic, then it's leap year. For example, if I take another year 1901, it's not divisible by 4, it's not a leap year. So the simple logic is if it's divisible by 4, it's a leap year. If it's not divisible by 4, it's not a leap year. There's just one extra condition in addition to that, that is that if a year is divisible by 100, then it's not a leap year, except if it's divisible by 400 also. So for example, this is a leap year. For example, 2000 is a leap year. The way it works is 1700, 1800 and 1900. These 3 years, even though they are divisible by 4, they are not divisible by 400. So they are not a leap year. So if you look at 1700, 1800, 1900, all these years, even though they are divisible by 4, they are not divisible by 400, and they are divisible by 100. So they are not leap years. So if a year is divisible by 100, then it's leap year only if it's divisible by 400. So 1800, 1700 and 1900 are divisible by 100 but not divisible by 400, so they are not leap year. That's the primary condition. And 2000, it's divisible by 100 and it is divisible by 400, so it's a leap year. So the first condition to check is actually not whether it's divisible by 4 or not, but actually that if it's divisible by 100, if a number is divisible by 100, then it should be divisible by 400 as well. So that's basically the first condition for finding if it's a leap year or not. If it's not divisible by 100, then if it's divisible by 4, then that's sufficient. So let's write a simple program which does that. So I'll clear this stuff off and let's get to writing our program. So let's first, the function is leap year. What we want to do is it should return 1 back if it's a leap year and return 0 back if it's not a leap year. So I'll start off. So if year is divisible by 400, if a year is divisible by 400 as we see earlier, so if it's returning 0, then I would want to return a 1 back because it's a leap year. So 400, 1200, 1600, 2000, all these are leap years. Next condition is if it's divisible by 400, if it's divisible by 100, then it's not a leap year. Return 0. The way this would work is actually if let's say I got the year input as 1600, then year mod 400 would be true and it would have returned the value 1. So if I pass in a value 1600, it would never get to the second if condition. So the second if condition would never get executed for a year which is divisible by 400. So this comes here only for years which are not divisible by 400. So the code comes to second if only if the first if is not satisfied. So if it's not divisible by 400, only then it would come here. So if it's not divisible by 400 and it's divisible by 100, then the number is not a even number. So sorry, then it's not a leap year. So I would return a 0 back. Then I would check if the year is actually divisible by 4. So if it's actually coming to this if it's coming to the third if, then it means that the number is not divisible by 400 and 100. So the only condition that I would need to check is if the year mod 4 is 0. If year mod 4 is 0, then it's a year is divisible by 4, then it's a prime even number. So now if none of the other conditions are satisfied, then I would return back a 0. So if you look at this leap year function, it first checks if it's divisible by 400. If it's divisible by 400, then it returns yes, it's an even number. Then it checks if it's divisible by 100. If this condition is true, if the second if is true, then it means the first if is false and the second if is true. That means it's not a leap year, so it returns a 0 back. And in all other conditions, I have to just check if it's divisible by 4. If it's divisible by 4, then it's a leap year. If it's not divisible by 4, then it's not a leap year. So let's just check if it compiles. That's good. It compiles, and the first input that I'm passing here is the year 2000. So year 2000, year mod 400 is equal to 0. So this is true. So it would just return 1 back and come back to the whole thing. So if I just go down and look at the output, you can see the output showing 2000 and 1 showing that it's a leap year. So let's continue, and now the value which is passed in is 1900. So 1900 mod 400 is not equal to 0 because 1900 leaves a remainder 300. So the code goes to the next if. So year mod 100 is equal to 0. yes, it is, because it's 1900. So it returns a value 0 back, and the function returns back to the whole thing. So if you look at the output would show 0. So 1900, the output shows 0 because it's not a leap year. So now let's go ahead, F7, the year passed in, if you look at it, is 1904. So it's not divisible by 400, it's not divisible by 100. So it comes to the next part, which is to check if it's divisible by 4, and it's divisible by 4, so it returns 1 back and it goes out. If you go out and look at the output, it would show 1904 is 1. That's a leap year. So if I now go with 1901, it's not divisible by 400, it's not divisible by 100, it's not divisible by 4, so it returns a 0 back. So that's not a leap year. So that's a simple program to find if it's a leap year or not. I could have further simplified the function to actually directly, instead of having a if here, I can actually directly return year mod 4 is equal to 0. But that's, for a beginning programmer, difficult to understand, so I left it as it is. Let's write a program to convert Celsius to Fahrenheit. If you look at the logic to convert a Celsius to Fahrenheit, it's very simple. All that you need to do is take Celsius and multiply it by 9/5 and add 32 to it. I could have written something of this kind, so Celsius into 9/5 plus 32, but it's confusing. You have no idea whether plus gets executed first, slash gets executed first, or star gets executed first. So to make it very simple, I've added brackets in. So the first thing which gets calculated is Celsius into 9/5, and to that 32 needs to be added. The program, I've created a simple function, Celsius to Fahrenheit. Right now it returns a value 0. So I've just created a float 0.0 and written the Fahrenheit back. From main, I've just invoked that function, passing in the value. So if I run this program right now, if you look at the output, it would just show me 0 degrees Fahrenheit. So the actual logic of the program is not implemented yet. That's why we see the output showing 0 and 0. So now let's go ahead and try and implement the logic. So the value of Fahrenheit is, as we looked at earlier, it should be Celsius. I have the input, the argument passed in, Celsius, into 9/5. So Celsius into 9/5 plus 32. So that's the value which we are returning back from here. So let's just check if I get the right value. Let's run the program and check whether the output is right. So if I run the program, I can see the output here. It shows 32 degrees Celsius is equal to 64 degrees Fahrenheit. Minus 40 degrees Celsius is equal to -8. But actually this is not right. The value for minus 40 degrees Celsius should be actually minus 40 degrees Fahrenheit. So that's something which I know, because that's the only point where the Celsius and the Fahrenheit scales meet. So there is something wrong in the way we did the calculation. The place where we did a mistake is here. What happens is any operation involving integers in any programming language, I think C, C++, Java, returns you an integer back. So what happens when I do a 9/5 here is actually 9/5 is 1.8, but since 9 is an integer and 5 is an integer, what happens is the decimal gets truncated. So 9/5 is equal to 1.8. The decimal part is truncated, that becomes 1. So whatever output we get is 1.8, but that's converted to 1, and 1 is used in the calculation. To make sure that something, to make sure that it's a floating point calculation, I would make one of these or both of them float. So I can do this 9.0 by 5.0, it's enough even if I do one of them to a floating point. So I'll also convert this to floating point because I want floating point addition here. Anyway, floating point addition would happen because the result of this would be a float. So even if I leave it at 32, float plus int is a float. So that won't be a problem, but just to be safe, in all floating point calculations, it's better to use floats. Okay, let's run the program and check what the output is. If you check the output right now, it shows the right values, 89.59. Okay, it's 89.6 and 40.0. So if 32 degrees Celsius is equal to 89.6 Fahrenheit and minus 40 degrees Celsius is equal to minus 40 Fahrenheit. So that's basically a simple function to convert Celsius to Fahrenheit. Let's write a program to do the multiplication table. So basically what we want to print is a table in this form. So if I pass in a number 5 and up to 10, so I want to print the multiplication table of 5 up to 5 into 10. So basically the output I'm looking for is something of this kind. 5 into 1 is equal to 5, and then 5 into 2 is equal to 10, and so on up to 5 into 10 is equal to 50. So this is basically the output I'm looking for from this program. This is called the multiplication table program. This is the first program where we are going to use loops. We are going to use something called a for loop in this program. Let's clear this stuff out and let's get to writing the program. So if you look at the program right now, it's very simple. I have a printable method with two parameters, number and up to. So basically if I pass in a parameter 5 for number and up to is 10, so I would want to print from 5 into 1 to 5 into 10. If I pass in a parameter 10, let's say number is 10 and up to is 20, then I would want to print from 10 into 1 is equal to 10 to 10 into 20 is equal to 200. So the way it would be is, we want to use a loop to print the value. So I would start with a very simple thing. So I would just create a variable int the count. I'll start with 0. It doesn't really matter because I would do the assignment here. So for count is equal to 1, I would want to go from 1 to up to. So I would say 1 less than equal to up to. So whatever 1 is, this loop gets executed starting from 1 to up to. So if I pass a up to value of 20, then it would run 20 times. If I pass in a up to value of 15, then it would run 15 times. That's basically what we want, because we want to print from number into 1, number into 2, number into 3, up to number into up to. So, and then the third parameter is count plus plus. If you want a detailed video on the for loop, you can look up the Java tutorial. Now let's just print %d, and I want a new line after each of the things, and I would say I want to print the count. This is just basic. All that I'm doing is print the count. So what should happen at the end of this logic is that it should print the print numbers from 1 to up to. So let's just say, just run the program and see if it's working. 1 to 10. So that's good. So now let's get back to writing the program. What we want to do is print actually something of this kind. %d into %d is equal to %d. So we want to print 1, the number, into the count is equal to the count value of number into count. So now I will pass the appropriate values. The first %d should be number, because it's the number which we want to print first. The second %d is count. So here the second %d here should be the count, but that is 1 to how many values which we want to print the multiplication table up to. The third value which we need to pass is actually number into let's run this program and see what happens. If you look at the output, it contains the multiplication table of 5 from 1 to 10. So this is a program that we wanted to write, and we can call this function for any multiplication. Let's look at how to write a program to find the sum of first n numbers. For example, if I want to find the sum up to 10 numbers, what I would want to find out is 1 plus 2 plus so on up to 10. So that's basically what I would want to find out. If I pass in a number 100, then I would want to be able to find the sum up to 100. So that's basically what we would want to write the program to find out. So it's called sum up to n numbers. I've named the function as sum up to, and it accepts the number as a parameter. The number is up to which number you want to calculate the sum up to. So it's sum up to 10, and I'm getting the value into the sum and printing it out. So let's write the function to do that. Right now it's returning 0 back. So if I run the program, okay, you'd see the output here, it shows 0. So now let's go ahead and try and implement this program. To do this, I think a very simple way of doing it would be to use the for loop. If I want to use the for loop, I would need to have a variable. So I would start a variable called count, and I would start it from 1. The initialization, anyway, I can do it in the for loop also. So int count is equal to 1, and I would want to go ahead up to number. So I would want to do it up to number, count less than number, increment the count, and what do I want to do? I want to sum the count. So I need a variable for holding the sum value. So I would start this variable at 0, and then I would do sum is equal to sum plus count. So, and here I can return the sum back. So I'll try to run this program and see what the output coming up. Okay, if you see the output, it's 55. It's correct. One thing you need to be careful about is right now I'm returning an int back as the value. If you want it to work for very big numbers, probably the right return value would be to use long, because when integer can hold 16 bits, that's I think up to 32,000, somewhere around 32,000. So if your sum goes over 32,000, integer is not the right value to hold it. Probably long might be a better value for it. Let's just debug this program and see how it works quickly as well. So I would add in a variable. I would want to add watches for sum, and I'd want to add a watch for count as well. So let's try debugging this program just to get a clear understanding of how and why it works. So now main is called, clear screen is done, and now the sum up to function is being called with parameter number as 10. So now count is starting at 1, that you would be able to see it here. Let me just take it back a bit. Okay, now you'll be able to see the values of sum and count as well. So sum is going to be initialized now. So sum is 0, count starts with 1, and now sum is incremented, and sum is equal to, so sum is equal to 0. After this, sum plus count, sum is 0 plus count is 1. So that result is stored in back in sum. So sum becomes 1. The count now is incremented to 2. So sum is equal to sum plus count. So 1. So sum plus count is 1 plus 2, that is 3, and it would be stored back into sum. So the next value in count is 3. So sum plus count is 3 plus 3 is 6. So 6 gets stored into sum. Now count is incremented to 4, and now the value of 4 is getting added to 6. So it's 10. Sum becomes 10, and counts get incremented as well. So 10 plus 5 is 15, and count becomes 6. 15 plus 6 is 21. 21 plus 7 is 28, 28 plus 8 is 36, 36 plus 9 is 45, and 45 plus 10 is 55. Count goes over the number, so it returns back, and it returns the sum back, and it's printed to the output, and that's it. So there you go, that's a program to print the sum up. Let's look at how to print the divisors of a number. First, what is a divisor? Let's consider number 12. 12 other than 1 and 12, what are the other numbers which divide 12 without leaving a remainder? So 2, 3, 4, 5 would, like 12 will not be divisible by 5, so 5 is not a divisor. 6, 7, 8, 9, 10, nothing else. So these are the 4 numbers I would want to print as divisors of 12. So that's basically the program that we would want to write. We want to identify what are the divisors of a number. So the simplest way to find if a number is divisible by another number is use the modulus operator. We have seen that earlier as well when we were trying to find out whether a number is even or odd. If we do a modulus of a number with another number, then we would be able to say whether it's divisible or not. For example, now if I do number mod 5, it would tell me if the result is 0, then it means the number is divisible by 5. So extending that logic, we would actually loop from, for example, for I is equal to, we would want to loop from 2 to the number. I don't want to include the number in there, so I put I less than number and not I less than equal to. So, and I do I plus plus, and now I can check if number mod I, that basically with I running from 2 to number, I'm checking whether number of mod I is equal to 0. If number mod I is 0, that means it's a divisor. So I would actually print that out as a divisor. So printf, I would do %d/n and say the number. I have to print I because I is the divisor of the number. So let's just run this program and see if it works. It won't because I have not declared I. Let's go ahead and declare I, and now let's go ahead and run the program. Okay, there you go. 2, 3, 4 and 6 are the divisors of this method. I'm calling it with print divisors 12. If let's say I would print divisors of 25, let's see what happens. It's 5 is the only divisor of 25. 24, 2, 3, 4, 6, 8 and 12. These are the divisors of 24. So this simple program actually helps us to print the divisors of. Let's write a simple program to find out if a number is prime. So I'll save this first. This is the same program that we wrote in the last video. This is used to print the divisors of a number. I'm saving it at. So now let's extend this program so that we would be able to find out if a number is prime or not. What is a prime number? A prime number is something which is not divisible by any other number except 1 and itself. So if you look at the number 12, it's divisible by all these numbers, so it's not a prime number. If you look at a number 5, the only divisors of this number are 1 and 5. So other than 1 and 5, no other number divides 5 directly. So the so 5 is a prime number. So I would want actually to find out if it's prime or not. I would say print prime number. If number is prime, I would want to print the number is prime. So I'm changing the function also, print prime, and I would want to print whether the number is prime or not. So now the way we identify if a number is prime or not is very simple. You can divide, if I want to find out if 5 is prime or not, what I can do is I can divide it by every number in between 2 to 4. That is from 2 to 1 less to that number. So 1 less to that number is 1 less to number 5 is 4. So I can try to divide 5 by all numbers between 2 and 4 and see if it's divisible, and then I can say whether it's prime or not. For example, if I want to find out if 9 is a prime, I would want to check between 2 to 8 and see if all the it's divisible by all the numbers in between 2 and 8. Sorry, if it's divisible by any of the numbers between 2 and 8, then 9 is not a prime. So the logic is very similar to how we found the divisors. I running from 2 to 1 less than the number. So we didn't use I less than equal to, we used I less than number because we don't want to do the modulus on the number. So if I is equal to 2 and I less than equal to I less than number, I plus plus. So if number mod I is equal to 0, then the number is, if it's divisible by any number, then the number is prime. So I can directly print number is prime, and I would say number percentage, sorry, is not prime actually, and the number is number. So what we are doing is saying the number percentage d is not a prime number because it's divisible, and I can return back because I don't need to check with any other numbers to find if a number is prime. If it's divisible by one number, then it would be divisible by then it's not a prime. Over here the code would come here only if it's divisible by all, if it's not divisible by all numbers between 2 and the number. So in that case, the number percentage d is prime. So, and I would print the number. If we look at the output, okay, so number 24 is not prime. So that's basically what is printed here. If I pass in a parameter, let's say I want to pass in a parameter which is prime. So let's pass in 71, which I know is a prime, and see if it returns. So number 71 is a prime. There are ways actually we can make this efficient. Like I can actually, instead of checking up to the number, I can actually check only up to the square root of number and do it also. So there you go. That's the program on how to print whether a number is prime or not. Let's debug this program to get further understanding of how it works. So let's pass in a number 11. I want to check whether 11 is prime or not. Let's do a debug and see what happens. So main is called and clear screen, and it goes to the print prime method, and number the number which we have passed in is 11. So now we are actually initializing a loop from I is equal to 2, so to I less than number. That's basically a loop from 2 to 10. That's the number which we are passing in is 11. So number we'll do the loop until I is less than number. That's basically until I is 10. So we would loop from 2 to 10. If you look at this, what happens now is I is 2. So if I is 2, and if you look at number mod I, it shows a value 1. That basically means that 11 is not divisible by 2. It leaves a reminder 1. So it would not go into the printf. So it goes to the next number, which is 3, and number mod I, when 11 is divided by 3, the remainder is 2. So it's not 0, so it's again not divisible by 3. Now it checks with 4. Now it checks with 5, 6, 7, 8, 9, and 10. Since it's not divisible by any of those numbers, it would skip them and it would come to the last statement and print that the number is a prime. So that's how it would work for a prime number. And for a non-prime number, let's just take a non-prime, which is 9. 9 is not a prime because it's divided by 3. How does it work for this? Let's just check. So it comes here, it does a clear screen. We go into the print prime method now, and we start the loop from 2 to the number right now is 9. So we are starting a loop from 2 to 8. So if number mod I, that's the number is 9 and I is 2. So number mod I, 9 when divided by 2 leaves a remainder 1. That's what we'd see in the watch window as well. It's not true, so it doesn't go inside the if. Now I is 3, 9 mod 3 is 0. So this condition would match, and now the printf would be printed. So if you look at the output now, number is not prime is printed, and it would return back outside the method. Let's write a program to find the number of digits in a number. For example, the number 240. This has the number of digits is 1, 2, and 3. The number of digits in a number 25 is 2. The number of digits in 2, 3, 4, 5 is 4. So that's exactly what we want to find out. The number passed in as input is the number for which you would want to find the number of digits. So the number could be 2, 3, 4, 5, 240 or 25, and I would want to return the corresponding number of digits back. So if you look at the program right now, there's a main method which invokes the number of digits, and at the start I want to find out the number of digits in 240. So that's basically what we want to do in this program. Now coming to the logic of the program is quite simple. If you take a number 240 and divide by 10, this gives you 24. Again divide by 10 and this gives you 2, and this divided by 10 gives you 0. So we count how many times we can divide a number by 10 before we go down to 0, and that gives you the number of digits in that particular number. So the logic is simple. I divide by 10 and check if it's 0. If it's not 0, I again divide by 10. If it's not 0, again I divide by 10 until I get to 0. And the number of times I execute the loop would give me how many times, give me how many number of digits are present in this number. The first time we are going to use the while loop. While loop is used in situations where I have no idea how many times the loop is executed at the start itself. For loop is more when I have an idea that I want to run this loop from 1 to number or 1 to something, but here I have no idea when to run the loop from to. So in this kind of scenarios we go for using a while loop. So what we want to do is, while I would copy the number, let's say int remaining, I would want to create a variable remaining to hold whatever is remaining at that point in time. We were looking at the logic where 240 divided by 10 is equal to 24. This one divided by 10 is equal to 2. This one divided by 10 is equal to 0. So I want a temporary variable to hold 240 at the start, then it would hold 24, and then it would hold 2, and then it would become 0. So that is what I call the remaining. So while remaining, we want to loop while remaining is not equal to 0. What we want to do is we want to divide remaining by 10, and we would want to also take the remaining value and store it in remaining itself. So remaining. So what happens when I say remaining is equal to remaining by 10 is the number gets divided by 10 and it would be stored back in remaining. To just get a clear understanding of what's happening here, I would add remaining to the watch expression, and let's try and debug this program. So let's get debugging at the start. So let's debug. The number of digits is called. I'm copying the number into remaining. So now if you look at remaining, it would show 240. So that's basically the value which is present in remaining right now. It's 240. And let's see what happens if I go further into the program. So it goes inside the loop. Remaining is still not equal to 0, so it goes inside the loop. When we do remaining is equal to remaining by 10, what happens is 240 by 10 is 24, and that 24 is stored into remaining. So if you look at it, the value 24 is stored in remaining. And now again I'm dividing by 10, so 24 divided by 10 is 2, and that value is again stored back into remaining. So remaining becomes 2, and now remaining is 2, 2 by 10 is 0, and remaining is 0, and it would come back out of the loop. The output is not important as of now because we are not actually written any logic for that. Okay, now to find the number of digits, we want to use a variable called count. So I'll store number of digits in a variable, number of digits. Initially it would be 0, and each time I come inside, I would increment number of digits by 1. So number of digits is equal to number of digits plus 1, or I can do simply number of digits plus plus. So at the end of this, now I would have number of digits. I'm returning it back. So as long as the while loop executes, the number of digits plus plus happens, and it gives at the end of the whole thing the number of digits in that particular number. Let's debug and see what happens. Let's clear screen, and now the number of digits get called, and remaining, the number is getting stored in remaining, and it becomes 240. So the number of digits gets initialized to 1. So I'll add another watch, number of digits. So F7. Now number of digits gets incremented, and remaining becomes 24. And again the number of digits gets incremented, so number of digits is 2, and remaining becomes 2. And number of digits gets incremented, that's 3. And now remaining by 10, 2 by 10 is 0, so remaining becomes 0. So now remaining not equal to 0 condition is false, so it goes out of the loop, and now it returns the number of digits back, which is 3. So if you look at the output, it prints 3 in the output and gets out. If I pass in, let's just run this program with different inputs, 24012, that should print 5. So there you go, that's the number of digits in 24015. And if I pass just one digit, it should print number of digits is 1. There you go. So that's the simple program to find out the number of digits in a number. Let's look at how to write a program to find the sum of digits of a number. In the previous program, we have written the program to find out the number of digits in a program. Sorry, a number of digits in a number. I've copied the same program out. I've just renamed the function number of digits to sum of digits, and even the main function I've changed it to invoke the number of digits. So now the main function would actually invoke the sum of digits. The expected output of the sum of digits program is very simple. If I pass in number 240, what I would want to be able to do is do 2 plus 4 plus 0 and give an output 6. So if I pass in a number 25, then I should do 2 plus 5 and return a number 7 back. And if I pass in a number 2, 3, 4, 5, then I should do 2 plus 3, that's 5, 5 plus 4, that's 9, 9 plus 5 is 14. So now that's the output that we want out of this program. This is the logic which we wrote earlier for the number of digits. The number of digits just keeps dividing by 10 until we reach 0, and we keep incrementing number of digits until we reach 0, and that gives us the number of digits. But what we want now is not the number of digits, but actually the sum. So I would change the variable number of digits to sum of digits. So now I would initialize that sum of digits to 0. Also I would change the watch variable as well, sum of digits, and I would change the program also to use sum of digits. So I would return sum of digits back. So the sum of digits is actually incremented here, but what we want is not the count of digits but the sum of digits. So what we want is when I actually divide 240 by 10, I would want the remainder. So let's say the input, the number which is passed in is 2401. When it's divided by 10, the last number is lost and it becomes 240. So it would become 240, and this when divided by 10 would become 24, and this would be divided by 10 becomes 2, and so on. Now what we want is really to find out the remainder. So I want the 1 when it's divided by 10, because what I can do is find all the remainders at each point and then sum all of them up to find out the sum of digits. So what I'm creating is a new variable here called remainder. So I want a remainder at each stage, and the remainder is the remainder when it's divided by 10. So remainder is equal to what I would want to do is remaining, whatever is remaining, that's like, for example, at the start it would be 2401. I would want to do a modulus 10, that's the remainder operator, modulus 10, and it would give me the remainder. That's basically what is the remainder when the remaining number is divided by 10. And what we can do next is I can add sum of digits is equal to sum of digits plus remainder, or in a simple way, sum of digits plus is equal to remainder. What happens here is the remainder gets, each time in the loop when a number 2401 is passed, remainder mod 10 would give me the value 1. Then I would actually divide by 10, so it becomes 240, and then I would get the remainder as 0, then I would get the remainder as 4, and then I would get the remainder as 2. And we would all, at each step we are actually adding the sum of digits, so this would give me the final output. Let's just debug this program and see what happens. I'm adding a watch variable remainder. The main method is called, the clear screen is invoked, and then the sum of digits method would be called. The sum of digits, I'm passed in a value 240, so now remaining is equal to number, so that becomes remaining would be 240. If you look at sum of digits, it becomes 0, and now remaining is not equal to 0, remaining is actually 240 right now. So now what I'm doing is actually doing 240 mod 10. When 240 is divided by 10, the remainder is 0. That's basically what you would see now. So the remainder becomes 0, and the sum of digits, to the sum of digits the remainder is added in. Since it's 0, it's remained 0. Now remaining is remaining by 10, so remaining becomes 240 by 10, that is 24. Now remaining is not yet 0, it comes in, remainder is equal to remaining mod 10, remaining is 24, and when it's divided by 10 it leaves a remainder 4. So remainder becomes 4 if you look at it here, and it's added to sum of digits now. So if you look at the output, sum of digits becomes 0 plus 4, which is 4, and remaining is equal to remaining by 10, so remaining, which is 24 right now, would become 2. Now it goes in the loop again, and remainder would be remaining by 10, which is 2, and sum of digits is equal to, the remainder gets added to sum of digits. The sum of digits is right now 4, so 4 plus 2, 6 would be stored back into sum of digits, and remaining is equal to remaining by 10, and now remaining becomes 0, so it comes out and returns the value of sum of digits. If you look at the output, it prints 6. So that's basically how the sum of digits can be calculated. Let's try whether the program works for a few other cases as well. So let's say I just pass in 2409. I would expect a result of 15. 2 plus 4, 6, 6 plus 9, 15. Let's see what happens. Okay, there you go, it's 15. And I can pass in even a different number. Let's just pass in 2-digit number. I passed in a value 29 and the output is 11. 2 plus 9 is 11. There you go. That's how you find the sum of digits of a number. In next program, let's see a little bit more complex program on how to reverse. And if you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.